What we have in here is the latest investment machine tool technology, Morrissey NT4250. This machine tool will allow us to produce parts in one operation. We don't need the castings, we will produce it from raw material.
Okay, and this machine would run unattended?
Yeah, this machine will run at night, so when the guys finish the shift, the machine tool will run right through into the morning. It will use the solid raw material. It'll produce parts such as this, which is a small part from a vision drag system, a very critical part of the function of the product.
And it produced that from a solid lump of metal?
Yeah, just a phosphor bronze bar in complete operation.
So quality control and tolerances must be really important.
Absolutely, with the latest technology and the capabilities and what we can actually machine and the products and parts that we can produce, it is critical that the finished item is to drawing and as accurate as it possibly can be. Now, this machine tool was part of that investment package, so we invested in the machine tools. We have a coordinate measuring machine that allows us to check what we've just machined, what's coming off the machine tool.
And 100 years ago, William Vinten started the company on the basis that the machinist checked his own work.
Absolutely, and that is still the case. So the guys in here are responsible for the inspection of their own components being run on the coordinate measuring. As you said, taking measurement around the part, which are then checked against the original drawing.
And what sort of tolerances are we looking at here?
Typically tolerances within this function or within this part, 12 to 25 microns.
Okay, and put that in context.
Cigarette paper is 100 microns.
Okay, so an eighth the thickness of a cigarette paper is the sort of quality control that you're expecting?
Absolutely, and all of that's being measured by that contact there. That part's come from the machining facility and come onto the line. This is the Vision 100 headline. The line is configured in a way in which the product builds gradually down the line until it's finished at the end and then goes for its inspection. In this case, this part is one of the drag components that's part of the first stage of the assembly process down this line, which we can see there.
And this is Vision 100. Each of the assemblies has its own production line?
All of our assembly lines are configured in the same way. This is Vision 250 assembly line, and it's configured in the same way as the Vision 100 assembly line.
And this is the drag assembly that will be a part of that head?
Yeah, that's correct. That's Vision 250 drag assembly in the early stages.
One of our challenges, of course, to find a fundamentally new way of moving the camera around which overcomes limitations of a conventional pedal and maybe offers new opportunities for creativity. And a good example of that would be in the field of robotics, where we can break free from the constraints of a human being operating the equipment to actually allow it to have a much wider envelope and have a degree of automated control which are beyond what a person can do. Electronics and software are the big areas of development now in products, where they're basically replacing a lot of the mechanical functionality. Whilst the core mechanics will exist, areas of their performance will be done electrically. And a really good example of this is image stabilisation, where mechanical solutions have reached the point of diminishing returns. Staying close to the market is very important in many ways. Naturally, there's understanding the current products and their limitations, getting feedback from the market, and contributing to sort of incremental improvements in the products.
Try and anticipate the problems before they become a problem, turn that into some sort of a solution, either a new product or a feature within a product.
Creating technology and products that solve tomorrow's problems, and hopefully surprise and delight the customers when they come and ask for them, and we've already done them.
I suppose engineering excellence is another one.
Consistency of quality in product, the performance of the product, the people. It's
often said that the simple solutions are the best ones, but often they hide the most amount of work and sweat to get there.
Everything from the initial purchase right through to the ongoing after-sales support, really.
Well, we have internal service centres, one here at Bury, France, Germany, East and West Coast in America, also Singapore and Japan, but also then further supported by our distributor network, who are engineers that have come here for training.
One of the things we pride ourselves on is that our products are underpinned by an analytical process rather than a trial and error methods, and as a result we can predict exactly how they're going to perform before we even see them.
What do you think your father would say if he could see it all?
I think he would be astounded at the size of the group. To think that grew out of his Border Street workshop. But what would really interest him is the machine tools that you've got in the Bury factory now. The computer-controlled machine tools, which throw up the parts at an enormous rate.
One of the things we do to ensure that innovation has its place and does not get overtaken by daily priorities is to have a formal innovations team within R&D at Vinten. This is effectively a ring-fenced resource that can devote its time entirely to innovative products, sort of sky for want of a better term, and explore things that in the normal run of a manufacturing company you don't get the opportunity to do.